Hi there. Welcome to Edgecon, everybody. Um, I'm honored to be here, and I'm so thankful that you guys could all join us. Um, I wanted to provide a quick intro before we jumped into the agenda, but before doing so, I wanted to thank everybody who sponsored ARM, DKIX, StackPath, of course, Vapor. We have been putting on these sort of EdgeCon events for many years now, and every single time we do this, thanks to the hard work that Candace and team have built, especially this year, the lineup just continues to get increasingly more robust with topics that are meatier and heavier than they were the year before. And what's really great about this year is, at EdgeCons, we often talk about building the killer apps for the edge, and we'll get into a little bit about that here soon as we sort of kick off the event. But what we're finding is that building those killer apps require incredibly complex reference architectures across a number of technology segments, and increasingly on the other side of that, people are trying to consume these capabilities with sort of one hand to hold. If you're a vendor, it's definitely one hand to hold. If you're a customer, it's one throat to choke. But we started with very humble beginnings, these EdgeCon events in Aspen. So you can see behind me the virtual living room. I wish this was actually my living room. But we started EdgeCon in the living room on a couch in Aspen, Colorado, very much in the style of an unconference for those that remember the Web Monsters days. We no socks, no shoes, a living room and a couch in Colorado. That's where we started. And so today, speaking to you in partnership with GSMA Thrive is just a truly incredible experience for me. And I think on behalf of all of the people that are going to be speaking with you today, we're honored to be here, and we're honored to share some, what I believe will be some incredible content with you. So I'm sure most everyone has seen the agenda. We'll jump into the first topic, which I'm delighted to be joined by Dave Ward, formerly global CTO of Cisco, now at Packet Fabric. Dave, could you do a quick intro?
Hey everybody, thanks for joining. And Cole, let's make this the edgiest EdgeCon we possibly can. The topic that you've got lined up to talk about, I think, is right in the heart of the industry right now, and something that you, myself, and a number of our friends are really passionate about. So thanks everybody for joining, and I look forward to it.
This is awesome, Dave. So look, you and I are old guard, which makes us old by definition. We've been in this industry a long time. And by the way, EdgeCon, we practice radical candor around here. So we're going to be, if nothing else, we're going to be completely truthful. We've both been at this for a couple of decades now. And a few years ago, you invited me to one of your events that you hosted at Cisco. And we actually started down this path, if you remember, kind of started on the path of, hey, what would it mean if an enterprise became a thick MVNO or an MVNO in general? We started kind of riffing on this theme. And so, it just seemed appropriate to kick this thing off, that we talk about we call it maybe provocatively the alt telco space. But at the end of the day, there's only so much spectrum out there, and it's either licensed or unlicensed. And I think that that's going to present a ton of opportunity for the people. So first, Dave, tell me how you are thinking about the alt telco space and where the enterprise both starts, finishes, and then we'll round this out with sort of who the players are and ultimately who's battling and who's winning.
Well, that's a massive question. So let Candace know now that the entire schedule is blown for the rest of the day. So look, when you and I started talking about this, and we kind of coined the term alt.telco kind of after a domain name or a bulletin board service, what appeared was that not only are there new entry players in how to deliver radio, there's new players in how to do IXC, there's new cloud players and a ton of REITs out there bringing up new colo spaces. There's new players now building network as a service as a direct competitor to MPLS VPN and traditional enterprise services. And there's even new, there were conversations about white box and the role of SDN and a number of these pieces. And also just the services associated with that, new storage cloud players and distributed edge storage players, securities completely rebuilt itself. And so the reason why Alt.Telco came together is when you look at this collection of new businesses and entrepreneurs that have come out to directly go after the space of the way that legacy services have been delivered, both from a technology point of view, but more importantly, or equally as important, let me say it that way, from a business perspective, disrupt both technology and business at the same time. There's a number of, we'll call them old guard, like you said, folks our age who have lived in the old world and realized that, wait a minute, the internet architecture needs an overhaul and the business of the internet needs an overhaul. And that's how Alt.Telco really has come together. Whether or not Gartner or others would call it a new market segment, really all new classifications of the market, I think, are coming upon us into 21 as companies begin to mature.
That's a super interesting point that you just made. And there's obviously, when you talk about the edge, if you're talking about the way the internet works, where's the edge of the internet? We kind of, is the edge new? I recently saw a modular data center that had been like sort of, making the rounds across social media, et cetera. And I happen to know that box is still very cool, very old box, probably updated for some new things. We've had modular data centers for some time. What is it about this moment in time that is so special about basically where the wireline and wireless networks are starting to converge?
Well, 2 points. One is, I was at Cisco 20 years. I was at Juniper a couple of years. I was at even networking startups before that. Every single one of my topology diagrams showed that the internet started at the gateway router and everything stubbed off of that. Take that architecture, rip it up, throw it away. It just doesn't exist anymore. The edge is your car. It's your mobile phone. And midpoint routers now are existing all over the place as we're seeing mesh networks being built, both in the home and actually out in enterprise and in metro spaces. That being said, the US, and we'll just take that look at it for a second, is really in a challenging situation of having such a diversity of wireline technologies out there. It's almost Noah's Ark. There's two of everything, it seems. And this gives the emergence of new radios to come into play that can actually deliver. We can talk about rural broadband, but we can also even talk about suburban and even metro access where you want very high speeds. Radios can come to play, particularly with the 5G. Look, I said it. There we go. First 5G of at least this segment. But that being said, I don't know a single enterprise employee or a single consumer that really cares about actually the access technology that they're using to get on the internet. And what's missing and what gives a rise to the edge is the convergence of wireline and wireless subscriber into one. I want to buy a unit of bandwidth from a provider, and I want that unit of bandwidth to be over whatever access technology I particularly own. And if I can't get that, well, maybe I'll just take private spectrum and maybe I'll just build my own network. Yeah. And I can be done with this and really just control my whole destiny. And that's really the rise of CBRS and in some cases, private LTE.
So you bring up CBRS, and thank you for bringing up 5G before we brought up COVID. That at least was the right order of operations. We'll let someone else bring up COVID, just because I'm sitting in my office and it's a gray day out here, and I just don't want to talk about it. But it's something we will talk about, and it's something we've been talking about as a community and as an industry for a long time. I do believe critical infrastructure is more important today than it's ever been in our lives. So we'll kind of leave that there. But you did bring up 5G and you did bring up CBRS, both very interesting in context of the edge against the alt telco or the enterprise telco that now is awarded, I think, some choice about how they potentially think through their wide area network, their campus area network, their metro area network. Like when you think about what's available in terms of licensed versus unlicensed spectrum, and you factor in the capabilities of some of the 5G sort of the prophesized sort of 5G return on investment, right? For the types of investment that go into the building of networks, i.e., in this case, network slicing. How do you think that the enterprise journey will happen over time, given that you could build a private LTE network slash future 5G network on 3.5 CBRS? You could also take wholesale spectrum, right, from one of the established old guard telcos, or you've got new entrants into the space like Dish, who have a huge amount of AWS spectrum, and you could take that spectrum and almost turn yourself into a cloud native, thick, mobile virtual network operator. How do you think the enterprise is going to sort of deal? And do you see some verticals doing things differently than other verticals?
So I do. So again, a massive question, but let's try and tease it apart a little bit. No matter what spectrum we're talking about, I think the most important thing right now to enterprises is the shortest amount of time, and we'll talk about latency and network latency in particular, the highest quality link and access between radio and cloud. Fundamentally, that is the most important conversation to do with anything to do with radio communications. How quickly can I get to cloud? Because my entire enterprise, productivity suites, collaboration, security, all my applications, for sake of conversation, whether it's SAP's, Oracle, Salesforce, Workday's, Autodesk, on and on and on, everything, the entire business is now in the cloud. And obviously, everybody does business off of any device they want, and especially mobile phones. So therefore, the shortest time from radio to cloud and the best user experience is critical. So therefore, how do these other radio technologies fit in? So in some cases, depending if you're a multinational or depending upon what type of enterprise you are, hey, maybe the use of public spectrum is fine. And maybe if you're one of the Fortune 10, Fortune 50 companies, you're going to buy into the network slice and say, I want 10 gigs, 100 gigs, whatever you want, and I want that end-to-end for my multinational corporation. Now, I limited it to that number, not only because they're very large and very wealthy corporations, but really, I think slicing is more than a panacea for all sins out there, because I don't see it scaling practically anytime soon. I thank all the gods that my radio friends have finally invented VLANs, but in reality, it just by the nature of the spec, these slices aren't going to scale. So it's very limited point of set of corporations. Now let's jump over to the CBRS piece and just the way that mobile communications is evolving. Remember that this disaggregated evolved packet core at the edge is a forwarding plane and a control plane for subscriber termination and billing and such. All of that head is moving into the cloud, whether it's one of the big CSPs or it's an MNO, or an enterprise is going to take it into their own hands and become an MNO. That separation between forwarding and control plane is a beautiful thing to occur, particularly for the edge, because the notion of separating those two and having the forwarding gateway deep next to the radios for the fastest and best experience onto the cloud, and having something else do the control plane and policy elsewhere that scales out in a different direction, again, is the right architecture, thus giving the rise to a number of our friends who are entrepreneurs building both MNOs, CBRS, and private LTE systems that have that natural disaggregation associated with it, along with the spectrum management to lay out within the enterprise. So therefore, we're right at that crux. The radio spectrum is not locked by legacy telco. It's there for very specific circumstances in very specific business operations. But now there's a whole lot of choices, and the choices do come down to cost, security, and vertical. So for example, if you're manufacturing or a large distribution center and you have a combination of Wi-Fi and CBRS in that massive distribution center, it's a beautiful thing. And it's a beautiful thing because now the mobile device, whether it has cellular capabilities and or Wi-Fi capabilities, is 100% always on, and you're not thinking about radio. Because let me go back to where I started a few minutes ago. Nobody cares. They just want the best connectivity, and they need their generic COTS devices to work. And therefore, all of these options are emerging, and all of these options will continue to emerge. Another vertical, just that's talking about the current situation. at least in the US, our healthcare has undergone a massive amount of aggregation consolidation, and therefore now needs a follow-up of IT unification, and there's security implications there, where actually having controlled spectrum of both Wi-Fi and then private LTE or CBRS would make a ton of sense. And what's interesting there, bringing the edge right back into this, we're talking about large files.
Mhm.
We're talking about the need to have large crunching of images and of data sets, and then, of course, to be able to understand across large number of patients and do some analysis of what potentially could be wrong. The point here, Cole, is the edge is critical not only for the communications part of it, the edge is also there just to run the business. And to put a final business point of this, the delivery mechanisms are from solution delivery partners who are able to make it easy to consume and turnkey for productivity as a service to an enterprise or to a vertical. And the business I'm in is network as a service, which is really just be able to program the internet exactly the way you want it on a private, secure fabric, and be able to connect to all of those cloud items at the highest possible speeds with the lowest latency. And so a combination of all of these new alt.telcos coming together, yours included at Vapor, are critical to make not only the change in internet architecture was a great thing for us to talk about with our shoes and socks off in the couch in Aspen, but from a business perspective, is the business future of how enterprises are defined.
Yeah, it's a super good point. So much to unpack. And just because you're not wearing shoes and socks on the couch in Aspen doesn't mean you can't care about the economics of it and the easy button of it. So that we'll dive into, I'm sure, as the day goes on here. But you said a couple of things, and I really think that this is probably the last question that we can discuss before we have time for maybe one or two questions, and then we'll move on to our next panel, which is equally exciting to me. You said something a couple minutes ago around basically what's your logical proximity to a cloud, because you could have a physical proximity, you could have a campus area network that is literally a block away from a hyperscale cloud pop, but your routing, your BGP route takes them up to some other city and then back. So if it's logically close to a cloud, what do you think that means for how the telco, the incumbent telco spectrum owner, integrates with the cloud company, who then has eyeballs on one of 4 or 5 or a multitude of wireline MSOs, meaning a Cox, a Comcast, a Charter, a Lumen, et cetera. How do you think about that? And then what does year 3 here look like? Are telcos, is it Outpost and Azure Edge Zones and Google Anthos running in the central office? Or is there a need for something that looks a little bit like a telex? Is there a need for a modern day 21st century carrier hotel that can help exchange all of the traffic? And I'm sure our friends at DKIX also have an opinion about this, but we'll wait for that.
Yeah. So we'll try not to steal their thunder too much, but I'm going to anyways. So look, the history to date was, as we all know, but to make my point, caches moved into the COs and head ends. Then there was metro peering, so that way they could alleviate the transport off of these networks. And guess what's coming next? Edge is the IXC. And it's either going to be at the CO or the head end from a traditional wireline point of view, or an IXC at the tower, or at tower aggregation, depending upon how the topology is laid out. That is clearly the architecture that's going to end up emerging. And it's not a notion of NNIs, although that's the technical term of what we're doing. It's really who can give me a private network interconnect, and who can do this with the redundancy of fiber, of spectrum, and then of the L2 or L3 technology I want on top. And that is a fascinating transformation of the internet architecture. No longer does the internet start at the gateway. It's just like the entire internet is now combined at all of these major, not even necessarily major, but all these edge IXCs, and you have access to, it could be Anthos, it could be all of the different services you mentioned, but it's also caches and it's storage. And from my love and my passion of building large networks and high performance networks, it all requires the last 10 years of where SDN had come from to actually now have a real-time orchestrated, automated, programmable, on-demand with a network with a cloud consumption model. And so what pulled me out of vendor space and pulled me into alt.telco was frankly putting my money where my mouth was and actually going and trying to build that.
Yeah, that's awesome. I remember almost a decade ago, you and I have a conversation about resiliency through routing. So this is, I think we're well on that path. I was just seeing here, there is one question. I think we have 2 minutes that we can get to. So Raymond asks, compared to centralized cloud, do you think energy consumption increases or decreases at the edge?
Interesting. So to answer Raymond's question, you can basically say, well, you have, by the law of larger numbers, you're going to have potentially more equipment at those edge. But what's different is, I truly believe, and I've seen this from edge architectures, can we remove boxes? And the fundamental way to reduce power, yes, we can go into silicon photonics and we can find ways to try and make the transfer from photons to electrons more efficient. And there are thousands of people getting PhDs on that. But from a networking professional's point of view, do I really need the 8 to 12 different frame and header lookups traversing a data center to actually make the right routing decision? Or can I begin to, especially at the edge, fundamentally remove those ports from building those data centers? I think that is a possibility. So to really answer Raymond, if the actual construction of the topology at the edge is fundamentally different than what we know from the butterflies and Harper-Torres and other types of architectures that exist in these mega data centers, necessarily, even the introduction of the edge data centers actually can be lower power.
I 100% agree with you. I think the less you have to cache from a routing table perspective over time, the less blocks you're going to need, and therefore the less power. But power in a distributed, centrally, logically centered, but physically disaggregated. Again, the question is, where does the internet start and where does it stop? And that is a great segue into our next topic. I'd like to introduce Alex Resnick, distinguished technologist at HPE and the chair of ETSI-MEC, to help us talk through the internet backbone and the wireless radio access network. Dave, it's been a pleasure. Hope to see you in Aspen soon.
Hey, thanks a lot, everybody. Have a great one.
All right, and welcome everybody to this panel. My name is Alex Resnick. I am a distinguished technologist at HP, and I also chair ETSI's MAC standardization group, and we have an excellent panel here for you for the next half hour. And if I can just ask the panelists to introduce yourselves, and I'm gonna start with Prajakta. Please.
Great. Thank you, Alex. Hello, everyone. I'm Prajakta. I'm a group product manager in Google Cloud, and I lead cloud networking, telco, and edge, and really excited to be here.
Thank you. Nebu?
Hey guys, this is Augustine Nebu Phillips. I'm part of the infrastructure business unit at ARM, responsible for enterprise networking and our edge strategy. Nice to meet you all.
Cool. And Ivo?
Thank you, Alex. I'm Ivanov, CEO of Dixon International, responsible for strategy and global market development. Great to have you all.
All right. Awesome. So let's not wait too long and kind of dive into it. Just to set the context a little bit, right? What we're going to try and address is, or at least address in the time that's allotted to us, is the push of the internet into the edge as close as, or very close to the end users, into the wireless radio networks, and what impact it has on everything that we're doing. And I guess the right first question to ask the panelists, and maybe I'll start with Iva on that, on this one, is what factors do you think determine when and how this internet edge or internet backbone is pushed out into the edge?
Yeah, a huge factor will be technology, of course, if it comes to 5G developments around the globe in different markets. The technology itself, as we know, very close to the IoT communication in general, and to managing the millions and 100 millions of different frequencies. From an interconnection company, as we are, as DKIX, we believe that also further factors are the general digitalization, the digital transformation itself. Really, if it comes to all industry segments, if it comes to different types also of communication on the enterprise level. But last but not least, and this is probably the most important one, is the application layer. All applications today, which are fancy, which are extremely popular in the business and in the private world, the business world, talking about the virtual desktops, fancy cloud applications, but even further beyond this, if it comes to e-manufacturing, etc., and in the private sector, like, you know, the games everybody enjoys today, they literally they do depend on every single millisecond. Also the live sport streaming applications. These are applications, they really depend on the closest as possible proximity to the edge, because every single millisecond counts, literally. And this is what we see as the major drivers there.
Okay. So with one of the factors with the edge is that the space and power are really at a premium there, right? And so what that's going to translate to in some way or another, right, is a much more costly, let's say, environment from all aspects for an application provider. So one interesting question would be, if you're an application provider and you're looking at your application, how do you restructure the application? How do you structure an application to take advantage of what is running at the edge and what is going to be available there? Let me throw that question to Augustine first, and then we'll go from there.
Yeah, thank you, Alex. So it's a great question, right? So from where we see, right, the applications, ideally, you wouldn't want to put too much instrumentations at the application level itself. Instead, one of our focus areas at ARM is to try to create some of these abstraction layers that the applications themselves can seamlessly move between, their current life cycle in the core of the data center out into the edge. So, this whole concept of write runs once and run anywhere. We want that experience to be maintained out into the edge, whether it is near edge, a few hops down the data center, well out into the far edge. If you add more and more platform specific characteristics into your app layer, it becomes difficult to maintain and orchestrate like over time. So one of our focus has been to create these abstraction layers so that these applications can take the best advantage of the best-in-class sort of features that each of these platforms at these different aggregation points at the edge can offer. So maybe it's a new security implementation, maybe it's a new packet processing engine, given that power and performance profile for that portion of the edge. So the application should almost automatically be able to take advantage of these features that the platform has to offer. So when we talk to our ecosystem, all the way from chip designers to board makers to OEMs, all the way to cloud and telco partners, right? We emphasize that the focus is on scalability and true sort of end-to-end, right? When you have an edge strategy, it's not just about having it from data center on just to a mid-haul type area, but it has to stretch all the way down. So that's sort of a philosophy that drives some of our strategies for the edge.
Okay, and this being an application question, I'm wondering, Prajakta, is there something that you want to add to Augustine's answer?
I fully agree with him. And he said something very important, which is when you're developing applications on the edge, honestly, the core best practices are just like when you develop apps for cloud, which means you build clean layers, you build clear abstractions between the layers. And if you really think of accelerators themselves, like they will take multiple forms and shapes. So whether it is improvements in on-chip accelerators, like for your general purpose processors, or you've dedicated accelerators such as GPUs, and then over the years, there will be the next generation of smart NICs and so on and so forth. So I think all of these libraries for common and application-specific functions themselves will become widely available and they will accelerate adoption. And I think even the performance sensitive portions of your edge pass capabilities, they will start being available on accelerators. And I'll give you one quick example, which is, you have GPUs and TPUs for AI and ML processing. So Google, for example, has an edge TPU. You obviously have NVIDIA, you've got AMD and several players in this space. From an application provider perspective, what they need is a layer of abstraction. So based on the performance they need or the workload they need to run, it should be seamless to them what's running under the hood, and it should be dictated by what the application needs as opposed to having to stitch something for each of these accelerators.
Okay.
I agree with that, yeah.
So I think there's a second question that this naturally leads into, and Prajakta, I'll ask you to start on this one, right? And it's a question about high service availability. I think there's a certain way of doing things that application developers are used to doing things with cloud providers like Google, for example, in order to get high service availability, right, and structuring things. As application components move to the edge, how do you obtain and maintain that high service availability, both from a service provider point of view and an application provider point of view, right? What's the division of responsibilities and how do each one of them act in an edge environment?
I think that's a great question. So as we start moving applications towards the edge, it is really about shared responsibilities. And honestly, the way to having resilient and highly available services starts with good architecture, good platforms, and good abstractions across the board. So we already spoke about this in the context of the prior question. I would say clean layers, clear abstractions, then also the architecture and the stack itself, because the application itself runs on something. The more cloud nativeness you have, and that doesn't necessarily mean containers or any specific thing. It means cloud native best practices. You're talking more everything in terms of services as opposed to infrastructure, software defined architectures, dynamic and optimized cost models. You're bringing in pervasive closed loop automation, whether it's through data analytics or AI/ML driven CI/CD and so on. So I think that's the first building block that we need to do properly. The second is the design itself. So you need to design for resilience at all layers. So for example, if your edge compute node goes down, have you designed for it? Or if your application instance goes down, have you designed for it? I would also say orchestration, where you're essentially balancing the workload across the compute capabilities. And this is based on, say, latency or compute requirements. Then there's the element of horizontal auto scaling. Also, several interesting things that the edge is bringing, which is if you require, for example, to be connected back to cloud, can your application or that entire deployment deal with being temporarily disconnected from cloud? Or are there instances where you need it to be fully disconnected? And I think one new thing is also with services moving across nodes, having a policy for well-defined cooperation, which means well-defined handoffs between edge nodes as you start seeing things move. I cannot overemphasize the importance of observability, analytics, and closed-loop automation. And I think the last bit I will add is SLAs. So we are very used to giving SLAs at the component level. The moment you have a global distributed edge with cloud, private cloud, and other things mixed in, we will have to start thinking about these end-to-end SLAs at a logical level instead of at a component level, which means either at the level of a service, an end-to-end application, or a slice. And the most attractive thing about this is you're now able to manage at service level, which means if an underlying component fails, you can easily swap it out. And without this, I think it's going to be extremely difficult to go deliver an end-to-end SLA. So this is the core of actually building out a highly available service.
Okay. Ivor, I was gonna ping this over to you, and I think one of the issues that high availability touches on is also the backhaul capacity from the edge to the internet, right? How big of an issue do you see this being, both in general, and I think there's a couple of, or a very big interest around the whole big space of machine learning as a big set, I wouldn't even say a use case, but a key tool that drives a lot of the use cases for what's going to be happening in the edge, right? How big of a problem is the backhaul capacity? Is it a problem? And if it's a problem, what are the issues that people need to be aware of? How is it going to be solved?
It's still a problem, of course, especially if we talk about rural areas with no proper infrastructure in place. There's still a lot of areas where we do not have a reasonable coverage of a proper state-of-art digital infrastructure in general, right? It starts with a power supply and ends up with a really pure layer one infrastructure, ends up with data center space, and of course solutions. But if you ask me about availability, reliability of services, resilience, there are three, from my point of view, talking about the perspective of interconnection. There is an answer of the edge interconnection. We have to bring interconnection closer to the edge, closer to this layer of solutions. Projecta has been talking about where. We at DAKIX, for instance, we talking about edge interconnection. We have a term of the a triangle. We call it triangle, consisting of 5G, IoT, and AI. Of course, these are buzzwords a lot of people do use today. But if we think properly about this is where the future will happen and needs to happen when we talk about interconnection in the edge. we have to have the technology at our end on the interconnection side, allowing to deal with interconnection of IoT frequencies and data traffic directly in the edge as close as possible to the users. We need to use AI innovation and technology to optimize this. And of course, we also need to have a very good prepared product range for the 5G technology. So this is what we have in mind when we talk about a smaller interconnection platform, literally an internet exchange or interconnection setup in a box. A small one, placed in a cell tower, placed close to a highway crossway. This is what we are talking about, and it goes hand in hand with the topic of latency. So the closer we get to the users, the closer we get to the cell towers with the interconnection, where of course proper backbone infrastructure can be used to aggregate, pre-aggregate locally, and not to use the existing aggregation hubs as the hubs on the East Coast, on the West Coast only. This is not edge and will not figure out the solutions in the future. So we're working on the box for the highway crossroads and the cell towers. This is where the future goes to.
Cool. I think everybody noticed how passionate I got about this, and I was going to ask if one of the other panelists if they wanted to add to what Ivor said about this.
I can give I can bring a slightly different perspective to the space from the viewpoint of ARM, right? You can think of ARM as essentially almost a horizontal sort of technology company. Right, so our priority is, and I will point to a recent example of the work that we've done with companies like VMware, where they announced an enterprise-grade workload like ESXi running on a Raspberry Pi. Right, so if you look at it, right, ESXi designed for data center and Raspberry Pi not quite designed for data center. We're seeing these two worlds merge, and we need to put these tools in place so that workloads like ESXi can run at the edge on, Raspberry Pi is a demo vehicle, but you get the idea, right? It's about running, and along with ESXi comes all these features that you almost take for granted, like high availability, fault tolerance. So as ARM, right, we work to enable these fundamental layers so that the ISVs can just make the best use of edge hardware that's out there.
So go ahead, Prajakta.
No. I was just going to say there were some extremely interesting points that both Augustine and Ivor brought, and the only thing I was going to add to that was I think like the 4 dimensions they mentioned. One is like latency, one is cost of bandwidth. I would just add regulations and ability to handle disconnections. Yeah. So when we start putting workloads at the edge, we are actually dealing with 4 parameters, if you will, and depending on which edge it is, the cost of bandwidth may or may not be the most critical one to solve for. But broadly, in terms of bandwidth pricing, I think one will be the ongoing decline in bandwidth pricing, but then also optimization of how much and what data we send back to core or cloud. And this will involve innovations to make sure we are discarding unuseful data right on location, or we're doing some amount of local training right where the AI ML inference is happening and then sending the rest to cloud. So I would just say that there's a lot of innovation happening in AI ML data analytics. And then eventually, I think there will be a point in the edge evolution where we will move away from granular bandwidth tracking. So and I think Ivor alluded to some of that with newer bandwidth consumption models, including all you can eat, because the broader value that you can unlock by the overarching edge solution and also the upsell opportunities, it will surpass the bandwidth costs. At least that's where we are beginning to see things land.
So I have a couple of questions from the audience, and one of them is quite interesting, I think. From the point of view of looking at the application design, do you think there's a difference between designing for fixed endpoints and mobile endpoints? And I'll start with Prajakta, and then we'll kind of go from there.
I would say yes and no. So let me maybe explain that answer. First, let me explain the no part of it. I think with the right application development environment and practices, you can really start insulating the application developer from whether an endpoint is on a mobile, whether it's on a laptop, whether it's an IoT appliance, whether it's fixed, whether it's mobile, and so on. And we are getting there in terms of abstractions. It's not like we are fully there, but I do think that we need to shield the application developer from these things. What we need to expose to them is a set of capabilities they need. So, for example, if your endpoint is moving, the application would want to be resilient in multiple locations because your endpoint is going to move. And then underneath layers need to handle this mobility. I would say that there is some amount of ease that comes from a fixed endpoint because there is more determinism. At the same time, there is a lot more flexibility that you may get with a mobile endpoint. So I would say instead of necessarily putting this lens on the application, we should see how we actually let the developer express the things they need, which is what kind of latency do they want or what kind of mobility characteristics do they want. And obviously, there's a trade off between some of this and cost. So there may be a choice which they make, for example, for critical applications versus some of your non-critical applications.
Okay. Augustine?
Yeah, I can add to that, right? So I fully agree with what Prajakta was mentioning, right? So I think one of the key things is to figure out what the platform ends up being. Whether it is crosses the lines between fixed and mobile. I mean, take for example Android, right? I mean, they've been quite successful in the mobile side. Now, on the edge, if you take an essential new function like orchestration, you're seeing that all these different variants of Kubernetes are lightweight, lower memory footprint variants of Kubernetes, like K3s, is coming out into the edge. So we're seeing these such kind of IP being developed for the space. So it involves some tweaking. But in many cases, again, derived from best principles that have sort of originated in the cloud domain.
Okay.
Actually, one more thing I'll add to that is and this is now more forward-looking, there is an area called ambient computing where you're essentially going and let's say watching a video on your phone, and you can, when you come home and you look at your TV, you can pour the video into your TV, which then when you walk out again, you can start seeing things on your smartwatch. And a lot of this is enabled by edge because there is nothing really running on endpoints except a level of programmability and interaction with some sort of an edge or a set of edge systems. So I think that is where the world is headed, and the less we make our developers do from having to figure out what type of endpoint it is, the more cooler the innovations we can actually go build out.
Okay, so I think we have time for one more very quick question, and I'll start this one with Ivor maybe, but what are the applications and services that you think, I mean, you're a decision maker, right? What's the path to near-term revenue? And it doesn't have to be an application, right? From AD, CIX, right? What's the business case for pushing the internet exchanges out to the edge?
As I mentioned at the beginning of this great panel, I literally believe all the applications which are extremely latency sensitive. And you ask me what applications are these? I think these are the applications in the future. Okay. All of them will be latency sensitive. Probably not all of them, but just look at our reality even today. The games we love, the communication we do, people who love to watch live sports events, virtual desktop applications, e-manufacturing, e-health, a real e-health solution and application where the virtual doctor visit, for instance, especially very important in the special times we are in today. they require the lowest latency possible. So latency is the new currency. And if we believe in this, we have to deliver the infrastructure which responds to this. So as infrastructure company, this is exactly what I see our job in, to deliver the infrastructure of the applications which are extremely latency sensitive, and to say the magic is below 5 milliseconds.
Mm-hmm.
All right, I think we have 1 minute left, so I'm gonna give a chance to Augustine and Prajakta to do like a rapid fire. If you have anything to add to Ivo's answer, and I mean rapid fire.
Yeah. I mean, see, from an ARM standpoint, right? We look at applications that are already being monetized all the way from transport layer apps, from top down. He mentioned cloud gaming, Android in the cloud. These are areas that we are actively tracking, and then for both ends of the spectrum.
Okay, Prajakta.
I will just add the 30-second answer. Broadly, enterprise solutions, I would say one is a set of horizontal capabilities, which is edge AI, vehicle connectivity, touchless transactions, mobile video like with drones, CDNs, media gaming. And then second, I would say is vertical solutions, retail, media, entertainment, gaming, manufacturing, industrials, and agriculture. I think those are the big areas to look at for immediate term.
All right, well, this is all the time that we have, unfortunately, for this panel. I want to thank Ivo, Augustine, Prajakta. This was a great panel. There would be applause if we had a live audience, I am sure. And for the folks in the virtual audience, please stay tuned for the rest of the agenda, which is going to be just as good. Thank you very much.
Thank you, everyone.
Thank you, everyone.
Good morning, good afternoon, and good evening. Welcome to what I know is going to be a lively discussion on the business models to accelerate edge computing. My name is Rhonda Acerto, and I'm Vice President of Research at the Uptime Institute. And I'm going to be moderating our conversation. I'm joined by three esteemed industry leaders, each from different areas of the edge ecosystem. And if I could please ask each of you to introduce yourselves and just briefly tell us a little bit about your companies. If we could start with you, please, Arash, then Matt and Thomas.
Absolutely. So my name is Arash Marsban. I'm the SVP of Product Management at StackPath. And the way I would describe StackPath is simply that we're an edge computing platform. That means we have everything from the connectivity to the compute horsepower in the form of VMs, containers, and et cetera, as well as in applications in the form of CDN and security with WAF to do any type of edge delivery that a client or user might want to do. So that's us in a nutshell.
Thank you.
And my name is Matt Trefiro. I'm the Chief Marketing Officer of Vapor.io, and we build edge infrastructure. We're essentially extending the internet backbone to the edge of the access network. I also co-chair the State of the Edge project at the Linux Foundation.
Thank you, Rhonda, and Matt and Arash. My name is Thomas Sweetala. I'm part of Edgecon Inc. in San Francisco. I'm an associate partner here. Edgecon is part of the Deutsche Telekom group. We're also proudly part of the Kinetic Edge Alliance, and we basically help with telcos internationally with their edge type of strategies.
Terrific. Well, thanks very much. So, we're going to be talking about the business models that may emerge around this next generation of edge computing, excuse me. And there are a lot of different directions we can take this conversation, but if I may, I would really like to start with 5G, because I personally have so many questions over who's going to pay for it, how is it going to be consumed, and, why are we waiting so long for it? It's not just going to be another 5G, right? But what are some of the business models that we expect will emerge from 5G? So I don't know who wants to start out with that.
I vote for Thomas.
Thomas, yeah.
the telco guy.
Yeah, there we go. Thank you very much for that. No, great question. I mean, 5G is basically going to be a revolution, in how we architect our networks. I mean, we've been coming really from a technology background, how we did, the previous Gs. Now the focus has shifted, predominantly to looking at use cases. It's not just about connecting people anymore, as we used to do. It's not about just communication, but it's about connecting devices. It's about connecting, certain things, IoT, to a platform, not just about connectivity, but also about managing certain workloads, processing workloads, and in that kind of sense, making our life, our connected life, much better.
So, Tommaso, can we talk a little bit about where we think some of the business models, some of the new business models will come out of that process? So maybe we just focus on this shift from CapEx to OpEx, right? Because it does enable more, having shared infrastructure, and there are so many components to delivering 5G. How is it going to be paid for, and who is going to pay for that? I know there are many scenarios, but what are you seeing out there?
Yeah, so what we are seeing there is going to be a fundamental shift in business models. We're going to see a shift into more subscription-based type of pay, for a specific service type of model, not just paying flat rate fees as we are used to. Mm-hmm. It's going to be about, charging for services, specific workloads that you would probably need to enable certain things inside the platform itself as well. Who's going to pay for? That's a very, very good question. I mean, the operators are looking at raising a lot of capital in that sense, starting to look at building a little bit more asset-light type of infrastructures. So getting rid of, the heavy tower infrastructures, or getting rid of, their fiber infrastructure into carve-outs that they are doing, so that they can raise the capital to be able to build this infrastructure for 5G as well.
Hey, Rhonda, I'll come at the 5G from a slightly different angle that I think will add to the conversation. So I think, to me, 5G is really three things. The first one, it's new capabilities and the new applications that are going to take advantage of those capabilities. And, we could go on and on about those, but they've captured our imagination. Then there is the cost. There's a massive cost structure in that we have to go to very high density of small cells or cell towers. It used to cost $200,000 to put up a cell tower. Maybe a few years ago, it was $50,000. We need to get it down sub 10,000. The backhaul networks are congested. We need to do a lot of work on the backhaul networks. So I think we have to figure out how to pay for a lot of this. But the third thing is that this is really the opportunity for the network operators to claw back some of the value capture that they lost to the over-the-top folks. And I don't mean that in a negative way. I mean they're going to pay a lot of money for this infrastructure, and there's going to be a lot of really interesting ways to monetize that infrastructure and create new dynamics with the cloud providers and the content providers.
Yeah, and I'll add to Matt, if that's okay too, which I think from where we sit and kind of one of the views we have is much the same, in that with that connectivity sitting at the edge, with the extended bandwidth that you'd have with 5G, whether it be millimeters or whatnot, the opportunity to actually monetize that in unique ways and create new ecosystems of services and platforms and products and applications that can live even closer to the customer, even closer to the end user and eyeballs and people, is absolutely fascinating. That's really what I think is going to propel the next generation of application delivery. There will certainly be new things that folks will dream up and build, but the performance and capability that you can now get with the advent of 5G or 5G becoming common is going to be very, very interesting to watch over the next several years.
Yeah, and maybe if I can add to that as well, there's going to be a lot more partnerships that can be established as well. Opening up this infrastructure as well, these platforms, opening it up for developers also. So there's going to be a huge amount of new type of applications that will be open to consumers as well, that can be delivered not just by the telcos as well, but in partnership with the telcos by developers as well.
And just sticking on partnerships for a little bit, what are some of the sort of unlikely bedfellows that you think may emerge in order to get 5G to where people want it to get to? I mean, thinking about cloud operators, what role do you see cloud operators in terms of partnerships with the infrastructure owners? Is there going to be a blurring? Is there going to be a true sort of division of investment? What are some of the, possibilities that you think are likely?
Yeah, I'd love to start that one off. I actually think that it's going to blur the lines in a way where if in the past the only capabilities that a provider was bringing in was just pipe, now you're moving to an ecosystem where, yeah, the pipe is certainly going to be there. And to Matt's point about it being a hopefully a very cost-effective, highly spread out, highly available deployment, that creates a model where that footprint can also be monetized and you can do interesting things with it. So with the advent of 5G, knowing that you now have greater bandwidth between, let's say, the tower and the end user device or your mobile device or whatever it might be, how do I actually get content there? How do I get decision making to that edge so that I can deliver content better, faster? If I'm doing advertising, how can I make better, smarter decisions about on-the-fly ad insertion or dynamic ad insertion? If I'm doing analytics for an IoT device, again, how can I do that better, faster, more immediately, and bring call it, instead of the centralized analytics and AI that might be able to live in a cloud, or ML that might be able to live into a cloud, how can I actually bring that to the edge? And as a telco, how do I monetize that? How do I enable, again, to kind of what Thomas was saying too, the application community to do interesting and clever things from there as well?
Rhonda, I think one of the things that talk about the cloud operators. I think one of the biggest changes that's happened as recently as the last 24 months is the partnerships that the telco operators are forging with the major cloud providers, and I think that comes from a realization that the cloud operators have just done a phenomenal job of attracting developers and attracting applications and at running data centers at scale. The telcos thought they could do that. They tried, in some cases, to go into those businesses. I think Verizon was the most prominent in the U.S. And Verizon essentially has divested itself from all those things and is focused on the network. And so I think if there's part of it starts to look like a Faustian bargain, but part of it also looks like 1 + 1 = 3. So I'm a big fan of the cloud providers and the telcos partnering. But the thing to realize, it's going to be a multi-telco world and a multi-cloud world. So if you see somebody announcing, what looks like an exclusive partnership, know that it really isn't.
Thomas, did you have anything to add to that? I think you're in quite a good vantage point.
Yeah, no, I agree with what is being said here. I mean, the thing about the cloud providers as well is they much more global than we, as telcos are. So telcos are very locally focused, So how do these global cloud providers actually work in partnership as well, together with the telcos to actually globalize them as well? It's not just about running like we used to with, high expensive MPLS type of circuits connecting businesses across the world. But now that, a telco can work together with a cloud provider and then offer some, very clever enterprise wide area edge solutions as well to customers wherever they are. It doesn't matter if the customer is anymore in their territory where their connection is as well. So the cloud providers are helping the telcos also to expand much more greater, much more international as well. And also, with what's happening at the moment with our distributed workforce, being able to address all those needs and connecting the customers then to the edge. So where the telcos are in the perfect position to be able to offer that real estate then to the cloud providers as well.
Certainly. So I think from my point of view, there's going to need to be some or a greater level of shared sort of back-end infrastructure here, because the cloud providers, not just for their global footprint, but they don't have the expertise nor the appetite, to directly invest in that infrastructure necessarily. I mean, I haven't seen that beyond like subsea cables. And please correct me, if you think I'm wrong. So where do we see the infrastructure, the costs and the management of that infrastructure and the development, the planning around it? To what degree is that going to be shared, do we think? And who is it going to be shared among?
Yeah, well, I think Arash and I actually have coming at that from different perspectives, but I think we'll sort of end up meeting in the middle. So I think one of the most powerful enablers of cost-effective 5G and edge computing is going to be shared infrastructure. When I say shared infrastructure, I mean from the ground up. So that is sharing fiber lines, it's sharing data center facilities, it's sharing servers. Because the economics of shared infrastructure are so powerful. I mean, if I have to build a data center, even a small one, for every server I need to put in the field, I'm going to run out of money pretty quickly. But if I can just lease a quarter of a rack from somebody that's already built a data center with some other investor's money, and I can turn it into an OpEx expense. I can get to market faster because maybe I wasn't thinking of pulling permits 14 months ago. So I think the shared infrastructure is going to be a huge economic and time enabler. Arash, you want to riff off that? You're on mute. Arash, you're on mute.
Thank you, Matt. Thank you. I muted myself just to make sure I didn't interrupt. So no, and it's funny. I actually we share probably a lot of concepts in common from that standpoint, where there definitely is an accelerant when it comes to having shared infrastructure and being able to leverage that core platform. And the question for me becomes, okay, well, what's the telco model, right? So from a telco standpoint, what's the most beneficial to them? Is it providing the footprint and then having other vendors operate out of that? Is it for them to actually own and operate their own platforms? And then on the other side of it, what's the right consumption mechanism? We've talked about developers in this conversation as well. So, is it platforms that want to run at the edge? Is it applications that want to run at the edge? Is it just analytics and data transformation that want to run at the edge? And so that creates a really interesting kind of, call it gamut of potential business cases, solutions, viable approaches to it, which is going to ultimately, in my view, it's going to be a balance, right? Like there will certainly be shared infrastructure, and there will be some partnerships and collaboration that's going to build off of. And then I think there's going to be a set that's going to look at it from the standpoint of like, hey, we want to own it end to end. We want to be able to actually make the edge a new, I don't want to call it a commodity because it's not yet a commodity, but the edge a commodity in the coming years, meaning they really want to own it. They want to be able to build value on top and go from there. And so I think we're going to see both in market, frankly.
Yeah.
I can certainly see merit and value depending on what the use case is for a particular business or solution.
And it's going to be different in tier 1 cities and tier 2 cities and tier 3 cities. I wouldn't be surprised if the major telcos do want to build out everything in some of, if not all of their tier 1 cities. But once you get into tier 2 and tier 3 in rural environments, the same incentives won't be there.
Absolutely agreed. Absolutely. And that dynamic is going to be very interesting because, again, the way the telcos operate, who owns what location, what region, even how they collaborate and how they sometimes share transit or use each other for last mile. I think that ecosystem it's going to become fascinating based on which providers have the time, energy, and vision to invest in what they want to do with their edge. And then how are they going to use that edge to differentiate themselves and support other companies in the process that maybe didn't build or didn't have an edge strategy early on. I think it's going to be really cool to watch.
Yeah, really interesting. I mean, I think you look at the tower industry, right? I mean, there was a day when each telco built and owned and operated their own towers, and they were just delighted to get it off their balance sheet and onto Crown Castles or other folks like that. And that created a huge economic advantage because now a neutral third party can lease it to the same tower to multiple carriers, and so you're getting a lot more utilization of that asset. And I think the same applies to fiber, the same applies to data centers, the same applies to servers.
Yep.
Mm-hmm. So can I throw in something there as well? Because it's also, we as telcos are getting ready to share even more, and with the entire disaggregation of the telco technology as well as playing a huge role in this. Why do I just have to, share the nuts and bolts if I can actually go and share as well compute infrastructure for my Cloud RAN or for running, virtualized network functions, which, I can then basically manage and control the software side, but the compute side, I can, dump that onto any, anybody who can offer that in a shared type of environment, like we did in IT with huge data centers and virtualized type of environments. So
yeah, there's an imagined future. There's an imagined future where some new operator comes into the market and builds its entire network on someone else's fiber and on Amazon or Microsoft or Google servers, and uses shared CBRS spectrum, and just completely changes the cost structure of some subset of wireless services.
Yeah.
So, Thomas, I just want to pick up on something you said earlier about this new type of asset-light carrier, I think were your terms.
Yeah.
Is that what you're referring to? Can you help me understand, what specifically you meant by that?
Yeah, exactly. I mean, it's kind of like where Matt was leading towards as well. I mean, it's, taking the things that, are not part of your core business anymore, and spinning it off, carving it out, putting it into a different company, or if you are a new company or new telco wanting to launch, that you can launch, in new environments without having too many nuts and bolts, many assets in that sense. You basically focus your business around services a lot more. You have a lot more platforms that you enable your services on, and you compete with your competitor on what type of quality of service you are offering to your customer, and you're not competing about real estate and where you are located as we did in the past.
Okay, got you. So what are you actually seeing today in terms of these innovations around these relationships? Particularly when we think about these over-the-top providers and the operators themselves, do you think there is going to be a blur there? Do you think there is going to be, a symbiotic relationship? I mean, what's the most sort of likely outcome?
I think everybody wants to work towards a symbiotic relationship here. So I wish that, and I hope that would be also the ideal way forward, because everybody can leverage on each other's strength in that sense. The telcos have the footprint; they still have the last mile. The OTTs don't want to get into that. The OTTs can respond much quicker. They do know the enterprise business a lot better than what the telcos do know. But then you have, again, the telcos who know the B2C type of market much better than what the OTTs in that sense when it comes to connectivity know better. So out of this, hopefully it will be a more symbiotic relationship, and everybody has to find their way and their feet in this type of relationship where they can add value. And I think that will also be something that's hugely beneficial to these type of partnerships, to develop new use cases, be able to develop new benefits for the users and for the enterprises, and for anything new that might come up that we don't even see on our radar at the moment.
Mm-hmm.
I really like Thomas's foundation of like that, and I know Matt's talked about it too, like where we all see it very similarly, in that there's always going to be shared components to this, and the symbiotic or the I do believe that, I know this is it's a kitschy term, but like 5G is going to, in a large way, actually make the edge less defined, and that means that you're going to have more applications move to the edge. And an excellent example of that is, you mentioned, an over-the-top provider. So they have the content, they have the platform or the information and truly the video, for example, that people want to see or want to consume. And so if you take that into account, I think the telcos are poised to do something really interesting, which is, yes, they can build an edge or leverage an edge, and they can sell it themselves. But more interestingly, they can actually provide a platform for over-the-top providers, CDNs, and many other types of services to actually run on. And that becomes very interesting. And it blurs the boundary of where these applications sit as, oh, it's IT infrastructure. No, I mean, it's your wireline, your transfer, the platform, the application, all start to merge into sort of this amorphous body that spreads across from the central cloud all the way to the edge where where you're asking for the content or using it. And that's really where I think the innovation comes from. And then we kind of talked about the other piece too, is that those telcos, yes, they've got the pressure. They're always going to have some pressure, if you will, from of being a dumb pipe, but that's not really what they are, right? And if you look at it, if you've got edge computing sitting at any one of these locations, this is an opportunity for them to really do another component, which is use that same edge platform for virtualized network functions, leveraging cloud native stuff. So if you want to run Kubernetes, if you want to run serverless, if you want to run containers, you can do that. You can run a router, you can run a network switch. And again, I'm oversimplifying just for the sake of conversation, but it's a really interesting scenario where, again, everything starts to aggregate on top of a platform that's agnostic to what's actually operating as the application layer on top of it completely. And that's quite fascinating.
Matt, did you want to jump in on that?
Yeah, one of the things that I'm most excited about is the lessons we learned from cloud and the iPhone. And that is, by lowering the barrier to entry for consuming vast amount of infrastructure and, I guess, device capabilities, just unleashes innovation. Whether it's Uber or WhatsApp, and so by the telcos and the cloud providers working together, they can dramatically create a platform that developers can program against, where the exact lines between one provider and the other don't necessarily matter, because it's been abstracted away.
Sure. So one of the big promises that with 5G, we mostly hear about it more as a consumer technology, right? And obviously there's a huge enterprise opportunity there. If I just think about IoT, for example, what happens to business resiliency and business risk management when you are using a layer upon layer of virtualized edge infrastructure? Can give me any thoughts around, what can we expect in terms of guaranteeing the service? And at the end of the day, if the service drops, who's responsible? or is that just an SLA issue? Any thoughts?
Well, there are cascading SLAs, right? I mean, but I think actually the SLA is really important, and that's where some of the monetization will derive from. So I'll give you one example. So in order to deliver a low latency service, you need guaranteed latencies, right? And the only way you're going to get guaranteed latency is if that last mile operator provides it to you and you pay for it, or the cloud provider pays for it and builds it into their thing. And that's what network slicing and some other capabilities are going to enable. So yes, I do think that the SLAs are really important. And I imagine eventually it's going to be auctioned off. You know, if I'm delivering a free game, I may only be willing to pay, you know, a penny to have a certain latency. But if I'm delivering, you know, an emergency service, or I'm controlling an intersection or a robotic factory, or, you know, whatever it happens to be, I may be willing to pay more. And I think those SLAs will be one of the ways that these new networking capabilities get monetized.
Yeah, and I agree with Matt. The only layer I would add on top of that too is that I think the application architecture is likely to change as well. So whatever applications are actually running at the edge, if they're doing IoT work, and to his point, which is I think is spot on, whatever they're doing is really going to dictate not only the application architecture, but then the SLA and quality of delivery below that, integrated into that, the stack itself is the compute and how it can run and how many nines go with it. It's going to be a really interesting kind of dichotomy over time. Add to that the fact that the edge is such a distributed world. It's not central cloud. It's not one location, one IT spot. I mean, you could distribute your application architecture among 500 locations or 1,000 locations and scale them as you need to. And that, again, creates so many interesting environments for data management, response, how analytics run. Again, sky's the limit as to what's possible. It's going to be fun to see what the really smart people come up with.
Well, thanks very much. Just quickly, Thomas.
Yeah, maybe if I can add two things. I mean, the first thing is, like was said, you know, it's more distributed, so I actually have more choice. So I don't have to stick with one provider. I can stick with multiple providers where I have. Mm-hmm. But the critical thing as well is what's happening on the security side. We've fundamentally changing how security is done at the moment with things like SASE. We're going into zero trusted type of environment. So when things are connecting, they come from a zero trusted aspect connecting into that. So that will give us, you know, I can use any type of infrastructure, but when I have to go into a specific application, that application has to identify, or I have to identify myself with that application to that application.
Well, folks, thank you so much. I feel as though we could spend another, many hours discussing this. I thought it was a great flyby. I just want to say thank you very much, Arash, Matt, and Thomas, and thanks to everybody for joining us. We are out of time, but please do stay tuned for our keynote presentation. But thanks very much, everybody.
Thank you, Rhonda.
Thank you, Rhonda. Thank you, Matt.
Thank you,
guys. Thanks, Arash. Have a great one. Thank you.
Too.
and back. Welcome to Azita Arvani, our keynote for today's talk.
Hello, very nice to be here. I'm Azita Arvani, General Manager of Rakuten Mobile Americas. I've been in telco industry for a while, and I've seen the transitions from 2G to 3G, 3G to 4G, and now with the 4G to 5G, this is really a huge step function forward. As an industry, this really gives us an opportunity to bring 5G to help other industries transform themselves. But at the same time, we need to seize the moment to transform the telecom architecture, the networks themselves as well. And so what I wanted to talk to you about today is really how 5G and the magic of mobile edge really come together. When we talk about 5G, we talk about all these wonderful capabilities that it can bring in, like the mobile broadband that enables us to bring in very high definition content, virtual reality, augmented reality. We talk about mission critical applications with things like autonomous driving and even remote surgery. Or we talk about having tens of billions of devices being connected to the network. So these are very demanding KPIs that we're expecting from 5G. And for that, we are going to be dependent on edge computing. So this multi-access edge computing, or MEC, really taking advantage of cloud computing at the edge of the network, will come in very handy. But in addition, as I mentioned, it's really important that for the telco operators really to think about the network transformation itself, because mobile network that's using the latest cloud and edge computing, it actually force multiplies the economy and the efficiency of the multi-access edge computing as well. And I will explain that as we go through the talk. We at Rakuten, we think about 5G at not the actual end, but actually a means to the end. So the 5G for us is a canvas where we try to make it as efficient as possible. So then we can put in all these other wonderful 5G applications on top of it to be able to help industries, help consumers, and help the society, the smart cities, and all of that. So if you think about our heritage, we have a company that's made up of over 70 different businesses. And all of these businesses are cloud businesses, whether it's be banking, delivery, logistics, entertainment, TV and so forth. All of those things are services that we would like to bring as on top of this 5G platform. So we really take the cloud nativeness and bringing that cloud native architecture to mobile networks very, very seriously. So as just an example of what a 5G network, 5G application could look like in the future, I wanted to give you an example of the 5G entertainment, for example, that can take advantage of the innovative edge computing. And I wanted to give you a little preview of that. okay, as you can see, that those interactive mobile entertainment services would not be available without the power of edge computing. And as you know, we talked about at the video about multi-view screens, live and on demand, being able to do commerce, interactive stats. So that's just an example of one 5G type applications that takes advantage of the edge computing. We at Rakuten really want to bring in this network transformation and make applications co-located with that network transformation to the world. We started with Rakuten Mobile, which is the mobile network operations in Japan. And we've also built this Rakuten Communications platform, which is an enabler for other mobile carriers outside of Japan to be able to bring that architecture, that cloud native architecture into their networks. So if you think about Rakuten Mobile, the world's first and still the only fully virtualized and cloud native mobile network, that Rakuten Mobile is a customer of Rakuten Communications Platform, which we call RCP for short. And if you think about RCP as as economists called us, the AWS for telcos, right? So we are offering a cloud platform that others can use, but in order to battle test that platform, we use it ourselves in Rakuten Mobile in Japan. And throughout this talk, I want to give you examples of how these two interplay and how they enable and create a edge computing platform in order to have both the network applications and MEC applications to run on. So we launched our 4G service on April 8, 2020, and that is a fully virtualized mobile network, and it's the world's first. And again, it's still the only one. And less than 6 months later, on September 30th, we've introduced 5G services as well, which I'll touch upon a little bit later. With the fact that we are doing this as a cloud native, fully virtualized Open RAN, Cloud RAN architecture, it really helps us with reducing the cost of that infrastructure and making it very, very efficient. And by doing that, we are able to pass those savings to our customers, to our subscribers. And also, we've decided to make it a very simple one plan. We call it Unlimited Plan, which we are offering to users unlimited voice, unlimited data, unlimited text. And the price of that service plan is less than half the cost of the average service plan in Japan. So by doing this transformed network, this cloud native architecture, not only we are very efficient for ourselves, but we are also making it easier for our customers and much more valuable to our customers. And based on the several months that now we've been on the service, I can tell you that this cloud native architecture is helping us with customers in big ways. We have seen a lot of traction with the customers. Even within the first few months of our launch, we've seen over 1 million subscribers signing up in an environment where we have fully saturated mobile market, in an environment where we have 3 strong incumbents, and an environment where we have to deal with COVID and all the retail stores are closed. So these are just based on virtual signups. And the fact that we're offering them a plan that's a very high value plan, we're actually seeing people consuming twice as much data as the average consumer. We're downloading lots and lots of videos, and we're offering the services on top of this rich communication services platform, which allows us to offer competitive, over-the-top like services, such as the voice and text, and the combination of the two, and in the future adding the commerce and other things to that, which I'll show you some examples of that. And that has become even more popular than the sort of old-fashioned voice over LT type service. Also, that kind of cloud native architecture gives us a very efficient way of operating the network. So these are just some KPIs to show you how we have been able to take advantage of the cloud for our telco network. So for example, it takes only 3 minutes for us to provision a mobile service, which usually takes about 3 hours in a traditional network. For us to bring up a 4G cell site, it takes under 10 minutes for a 4G cell site. And in a 5G cell site, we've improved that to be under 5 minutes. Now, if you compare that with a traditional network, which is now cloud-based, that takes 3 to 5 days to bring up a cell site. When we talk about new features, we're talking about a few days to bring up new features in this cloud-native environment versus in a traditional network environment. It's on a twice a year type of a cycle. And also when it comes to support personnel, it's really, really important to note that for a normal operator that's not cloud native, we're talking about 1 field technician per 1,000 subscribers on average. And for us, it's 1 engineer, 1 service reliability engineer for every 20,000 subscribers. So that's 20x productivity. So going to the cloud has really helped us with much, much more efficient operations. Now, when we think about Cloud RAN and MEC applications, they are truly a perfect pairing. And that also happens to be the title of an ETSI white paper circa February 2018, because the economies of co-location that you get with creating these edges in the network for Cloud RAN applications, in addition to being able to host the MEC application, it really provides a perfect pairing. And I will explain that as we go through our architecture. So our architecture in Japan, and of course with RCP, with our Rakuten Communications Platform, it's very flexible. It could go into multiple layers. But what we have in Japan is made up of 3 tiers of cloud. So we have what we call the edge data centers, which is kind of like the far edge. We have the regional data centers, and then we have the centralized data centers. Because we have gone fully virtualized and done this Cloud RAN, which is the hardest nut to crack in terms of virtualizing telecom functions. So we've gone through a big effort with our partners and ourselves, trying to make these radio workloads to run like an IT application on top of CUTS hardware, which cuts down a lot on the cost. So those very real-time radio workloads are sitting on our far edge data centers. Then we have the regional data centers that have the less real-time functions running. And that could also co-locate the MEC applications, all these wonderful 5G applications that we talk about, such as the entertainment service that we saw a preview of earlier, could run on the regional data centers. And then we have the centralized data centers where you have the non-real-time parts of the network functions to run on top of. And that could also host applications as well. So by creating this Cloud RAN that's bringing tons of savings by going from this tightly coupled hardware and software into an open RAN type of architecture and having them run on commercial off-the-shelf servers, we're saving tons of money in CapEx. In addition, by introducing the automation for all of these functions that we have, we are able to really lower the cost of operating of our system, and we are actually aspiring to be a level 4 autonomous network with adding more machine learning and AI operations to that. So our goal is to have zero touch operations And with that, we would be reducing our OPEX more and more. We're experiencing about 40% reduction in CapEx and 30% reduction in OPEX. But of course, these numbers will vary depending on the operator. But then we expect to see more and more of that as we delve more into automation. So this telco, this cloud-native telco platform is not only good for providing a great underlying network architecture for us in terms of providing connectivity to our customers, but it also helps with providing those demanding 5G applications that could sit on different parts of the edge here on our network. Going a little bit more into the Cloud RAN, just to show you how flexible and efficient this architecture is. On the left-hand side, you see what a traditional cell site looks like, which you see a tower with the radio and antennas sitting on top of the tower. And at the base of that tower, you see this big cabinet, which we call BBU or baseband unit. And that's where it houses lots of different kind of hardware that helps with the processing of the signals and data. And that, because it runs a lot of the real-time operations, it's sitting at the bottom of that pole in a traditional model. What we have done is we are taking that tightly integrated hardware and software monolithic tower and turned it into virtualized software that runs on the edge of the network in a data center. And that's what you see depicted on the right-hand side. By doing that, we are not only reducing drastically the amount of costs that we would have to go into the hardware that's purpose-built, and it's sitting outside in a cabinet, which needs to be weatherproof, and it needs to be maintained by people actually going to the site. Now they could be automatically managed in a data center. But it also helps with provisioning. On the traditional model on the left-hand side, when you provision that baseband unit, you have to provision it for maximum traffic that you expect to go into that site. On the right-hand side, taking advantage of the cloud computing, and in this case, the edge computing, we are taking advantage of the scalability of software running on top of cloud's hardware in a sense that if less traffic goes to the site, we scale it down. If more traffic goes to the site, we can scale things up automatically very easily. Also, instead of having this entire piece of hardware being dedicated to just one cell site, we can have it running multiple cell sites by connecting our software to multiple cell sites very easily. So we get tons of efficiency, both in terms of the investment and also in terms of the operations. And because we're running Open RAN, we're able to bring in the best of breed vendor, in this case, radio units, but also software units as well from different vendors, depending on the scenario that we're using. I want to show you a picture of what it looks like when you have a base station that is drastically simplified. So what you see here is just the radio units and antennas on top of the tower. And as you see at the bottom, there's nothing at the bottom. And that's what we call a zero footprint. And that, as you can imagine, has all kinds of efficiencies. And because of that, we've been able to accelerate our cell site deployment. So by first quarter of next year, we will be covering 70% of Japan's population, which is much faster than what our commitment was to the government. We are adding more and more services on top of RCS to our application called Link. We have a number of applications already with the banking, with mobile wallet, with credit cards, etc. And as you can see at the bottom, we have a pipeline of other services that will be launching soon. Our 5G launch happened on September 30th, as I alluded to earlier. And again, because we have a very efficient cloud-native architecture, that we are able to offer 5G on top of 4G at no extra cost. We call that Tada 5G, which in Japanese means free 5G. And because of since in 5G we're supporting different kinds of spectrum, like sub-6 and millimeter wave, we are able, with our open architecture, bring in the best of breed vendors of the radio for those spectrum. We have 6 regions that we cover today, and of course that's accelerating very quickly. And we have a portfolio of phones that will be expanding quickly as well. Just in the interest of time, I wanted to mention that our 5G is really taking our cloud architecture to the next level. While our 4G started with virtual machines, our 5G has gone into containers and microservices architecture sitting on top of Kubernetes. And that has given us even more scalability at lower cost. As you know, containers can perform at bare metal performance versus virtual machines are slower and less efficient. They are lighter, they can come up faster. So that's given us a lot more efficiency. On the hardware side, not only we're running on COTS hardware, but we've been able to reduce the flavors of that COTS hardware from 6 flavors that we had in 4G to down to 2 flavors. So again, our cloud in 5G is even more efficient. Security we take very, very seriously because, of course, in the open networks, you can leverage the fact that you can put more visibility and more control points in different parts of the network. So we start with trusted supply chain, trusted partners, but we have the zero trust security posture that continuously monitors and manages the security. And we've been recognized by the State Department as a 5G clean telecom company. Just a minute on the Rakuten Communications platform, which is the enabler for our own service in Japan, but also what we are offering to other mobile carriers here in the Americas and then the rest of the world. It's a cloud architecture that is in 3 layers. The base layer is a cloud architecture based on the very latest Kubernetes and container-based cloud platform, and that is running on top of COTS hardware, and that's hardened for telco requirements. So it's a telco-grade, state-of-the-art cloud infrastructure. On top of that, we have our network functions that come from best-of-breed partners. So our virtual RAN from the best-of-breed virtual RAN vendors, our core for the best-of-breed core providers, and so on and so forth. And we onboard it in a way such that it runs as a holistic system as opposed to just stitching together a bunch of point solutions. And all of that is controlled and managed and run by the intelligent and secure operation, which is an overarching layer. You can think of it as in telco lingo, OSS++, and that's where you have one window, one dashboard that makes everything in your network visible. You gather the data from your different network functions, even if they're from multiple vendors. You gather the data, you analyze it, you run the ML and AI models on it, and you're able to analyze it and manage and do predictive maintenance, and all make a lot of automation happen in your system. So that's what we offer RCP to others, and we are offering it in an app store-like interface. So we want to make it as easy as possible for operators to be able to order as much functionality as they want. So in conclusion, I want to go back to the notion that 5G offers a lot of different kinds of capabilities, but they need edge computing and take advantage of that multi-access edge computing, the edges of the network. And by having a cloud native network, we're really providing those edge networks that we can co-locate these very capable 5G applications on top of. So with RCP, we're offering that cloud native network to other mobile carriers, and Rakuten Mobile is one instantiation of that. So you can actually see that this thing is not just a pie in the sky or a proof of concept. This is something that actually works, that is scaled and is commercial, and we have subscribers that can attest to that. So thank you very much. And I look forward to discussing this with you either now or in the future occasions.
Wonderful. I want to say a huge thank you to Azita Arvani for joining us today and being our keynote. We greatly appreciate you joining us. And we appreciate all of our speakers for today. This has just been such an amazing session and such a great lineup. We hope you enjoyed the conversations as much as we did. And a very special thank you to our sponsors, Vapor.io, StackPath, ARM, and thank you so much for joining us for this lineup for Edgecon. We hope to see you at another Edgecon soon. And goodbye and take care.
Thank you. Bye-bye.